I wanted to make a video on Phistomefel's new cave puzzle because this is one of those puzzles where you can get to the answer without ever really understanding the puzzle. And myself included, the first time I solved this, I made a lot of assumptions and I sort of found the answer just by trying various options until it was like, okay, well, this one works. And the solution code was valid, but I still didn't really understand why it had to be unique. And it took me a long time to actually properly solve this puzzle, and in doing so I learned a lot of interesting things about infinite puzzles in general. So that's what I wanted to talk through today. We can start out with some pretty trivial steps. This cell can never be shaded because then these 2's would become at least 3. Cells like this or this can never be shaded because then this 3 would become at least 4. And now we get to the first deduction that's probably going to be a write-in for anyone who plays cave puzzles on the regular, but takes a little bit of extra effort to understand why it also applies in an infinite cave. And that's that this cell can't be unshaded because it would complete this 3 clue, and in completing this 3 clue we make a checkerboard pattern on these 2 3's. And in a regular cave, the reason I can't have a checkerboard pattern is because no matter how I connect these unshaded cells to each other, it's going to trap a shaded group between them. And the same is true in an infinite cave. The only difference is that instead of this shaded group having to connect to the edge of the grid, now this shaded group has to connect to this shaded group. And so no matter how these 2 unshaded groups connect, which they must do in some finite path, they're still going to isolate this shaded cell in a finite region, and it will be unable to join to this one without crossing over the unshaded cells. So we get all of these as shaded, and then in order to avoid a checkerboard, we get all of these corner cells as unshaded. Again, to avoid a checkerboard, we also can't have a cell like this be unshaded, because then either we're shading this cell to make this a valid 3, but then we get a checkerboard, or we're unshading this cell, but then this would become at least 4. So these cells can't ever be unshaded. Which now finishes off all of these 3 clues. So now we get our first interesting bit of global connectivity logic. Since I can't connect through any of these 2's, if I try and unshade both the cell above and below a 2 to make a channel through here, then it's becoming at least a 3. So for all of these 2's, I've got either a shaded cell beneath it or I've got a shaded cell above it, and I'm creating sort of a wall of shaded cells wiggling between these 2's infinitely inwards and infinitely outwards that's cutting off the grid at that point. So in order to connect the unshaded cells in this top left quadrant to the unshaded cells in this bottom right quadrant, we have to come around through the top right somehow. And that means that these cells can't all be shaded. I can't have all infinity of these cells shaded, or else I'll have 2 of these sort of shaded lines cutting the grid in half and disconnecting the unshaded cells. So at least one of these has to be unshaded. Let's just say that it's this one. That now is interesting for a couple of reasons, but in particular this shaded group can now no longer connect out through here. It has to get connected to the rest of the shaded groups through here somehow. In particular, it has to use this cell, because if it didn't use this cell, it would be coming down here, and then the checkerboard pattern with this one would trap this 3 in. It would only be able to get up to 2. The other way of seeing this is that if I try and make this 3 extend down here, then we're getting another checkerboard here with these unshaded cells, and that's creating a loop around this shaded group, which now can no longer escape. So this cell has to be shaded. That is then going to force this 3 to come out here. It doesn't want to become a 4, so this is shaded. This 3 is going to come out, and you can see we're going to get this cascading outwards effect. These 2's don't want to join to these unshaded cells, so I can shade in these cells as well. And if you're just playing this puzzle casually, at this point you'd probably feel justified in saying, okay, great, all of these cells are shaded. But that's not actually true. And one of the most interesting points in this puzzle, I think, comes from understanding why we can't have a situation where these shaded cells propagate outward infinitely. But then at some point, some random position, let's say position 152, they decide to switch from being entirely shaded to being entirely unshaded, and then having these unshaded cells propagate inward infinitely. You'll notice this still satisfies all of the 3 clues. It still satisfies all of the 2 clues. These ones would be capped off on the bottom, and these ones would extend out through the bottom. We can still get connectivity of the shaded cells because this group is all connected through here. These shaded cells could all come out here and get connectivity around the side. And we still have connectivity of the unshaded cells, which now these unshaded cells can all come out here, swing around, and join to their friends over here. So why does this not work? And the key point here is that these shaded cells, in joining out to the rest of the grid like so, they're creating a second shaded wall that propagates inward infinitely. So now we have this wall cutting off connectivity and this wall cutting off connectivity. And you might say, that's fine, I can still connect these unshaded cells to these unshaded cells by walking back out until I get to position 152, following the unshaded cells around, and then walking back in until I get to wherever I want to. The reason this doesn't work is very similar to the checkerboard logic and other similar ideas, in that no matter how I connect this group of shaded cells to this group of shaded cells, I'm going to trap a group of unshaded cells within it. So for instance, if I try to connect around here, then I've created a loop going around here, and then these 2 groups of shaded cells connect inwards infinitely. So even if I were able to somehow connect these unshaded cells through the point at infinity, it would still not be a valid solution to the puzzle because they have to have a finite connection to the rest of the unshaded cells. And similarly, if I try to connect the shaded cells around through one of these channels, then I'm isolating this group of unshaded cells within it. The only way I could possibly make something like this work is if this entire area over here was shaded, which is obviously not going to be good for any of these clues. So the key point here, and the reason that I know all of these cells are going to be shaded, is not that I have one unshaded cell in this group. It's actually that I have an infinite number of unshaded cells in this group. Because if at any point I ran out of unshaded cells, traveling inwards towards infinity, then the rest of these would all become shaded, and I would get 2 walls of shaded cells entering the center. And similarly, traveling outwards towards infinity, if at any point I stopped having unshaded cells in this group, then the rest would all become shaded, and I would get an infinite group of shaded cells extending outwards towards infinity, which would cause the same sort of connectivity break with these 2s, in that no matter how these groups coming in from infinity connect to each other, they're going to isolate unshaded cells traveling outwards towards infinity. So specifically because I know that there have to be an infinite number of unshaded cells in this group, that means I know there's an infinite number of these shaded groups that need to connect in, and as soon as one of these shaded groups has to connect in, then we get everything above it being shaded as well. And so that's what allows me to propagate this pattern all the way down to infinity and all the way out to infinity. Okay, now we can go back to the easy deductions. This 3 can't connect to these 3 or else it would make 5. So this is shaded. avoiding a checkerboard there. This unshaded group has to get connected, so this is unshaded, which now connects to this 3, which finishes that 3 off, so we get this all shaded in. This now doesn't want to join to this 3, so we get this shaded, and you can see this is going to propagate inwards infinitely, so this is a pattern that we can continue. And similarly, it's going to propagate outwards infinitely. Once I get this 3 completed, then I have to shade this cell up here, avoid a checkerboard. This unshaded group has to get connected out through here. Last key point to finish off these 3s is that this 3 can't connect down to here. Otherwise, in order to be a 3, I'd have to shade this cell and we'd get a checkerboard. If I unshade this, it's becoming a 4. So this has to be shaded. So this 3 completes with this cell, and this is shaded. And that's going to be the same for this 3, that's going to be the same for this 3. And so this side of the grid, it's much easier to see how it propagates inwards infinitely and outwards infinitely just through basic cave logic. Now these 2s have to come down, and they can only come down one cell before they're complete, at which point they're going to have to turn outwards into the 5s. These cells being unshaded complete these 3s. And these cells being shaded mean these 3s have to take one more. And you can see now, once again, I'm running into a situation where I don't want a big wall of shaded cells here, since I already have one in the grid. So I need an infinite number of these guys to be unshaded, both infinitely far inwards and infinitely far outwards. And here's yet another point in the puzzle where you might be tempted to just say, okay, well, I've got my pattern repeating on 2s up here. If I have a repeat on 2s down here, I'll just shade all of them in. And you can do that, and that'll solve the puzzle. But it ignores the fact that this pattern might not repeat on 2s. It might repeat on 4s or 6s, or it might not even repeat at all. It might be that there is a valid solution to this puzzle that involves, like, you can place these shaded cells anywhere you want. For instance, I could unshade this one, and then I could have these 5s join in through here, and then through here, and then through here, and then through here, and then finish there, and then have a group of 3 coming out next, and then a group of 7, and then whatever options I want. The pattern doesn't necessarily have to repeat in order for there to be a solution to the puzzle. It just has to repeat if there is a unique solution. And for that reason, I don't think you can say anything about these cells at the moment without looking at the rest of the grid first. Maybe there is a way. I haven't looked too far into it. But I think the way I would proceed at this point is to now look at connectivity going into the grid. And notice that we have a pretty big ring here that's trying to cut us off from connecting in. And more so than that, we can't connect in through the 5 channels. Now, I just said that the 5s have a lot of options. The point is, I can't come into the 5s and then come back out. If I try to do that, if I try to connect in through here, say, this 5 is now complete. It's a completed clue. So I unshade both of these, and I can't ever enter the ring through here. If I try and enter it through a channel out here, I get the same problem. I immediately shade off both of these, and then I can't get in any further than that. So in order to get connectivity into this ring, the only way is to come through here. Similarly, we have to come through here. Similarly, we have to come through here. And I can do exactly the same thing, same sort of thinking for this slightly larger ring. How am I going to get these unshaded cells in through here? They can't come in through the 5s because the 5s don't work like that. So they have to come in through one of these 2 channels. And importantly, what that means is that both of these 9s are seeing at least 3 in the column, 4, and then whichever of these are unshaded, 5, 6. So now if I tried to unshade this cell, that would be 7, 8, 9, 10 out here. And we would be breaking the count. So I have to shade this. And now in order to complete a 9 like this, I need 1, 2, 3 in the column, 4, 5, 6, 7, 8, 9. That finishes off now both of these 5 clues, so I get all of this is shaded. And now I actually can propagate this inwards and outwards because the logic is exactly the same for all the subsequent rings. And that is the unique solution to Phistomefel's infinite cave puzzle. Like I said, you can kind of see the solution once you start to get going. But actually figuring out why it is the only possible solution, especially when you include solutions that are non-repeating, or that repeat infinitely outwards and infinitely inwards, but have a switch somewhere in the middle, it gets a lot more complicated than you think to actually work with these sort of grids. And I learned a lot more playing around with this puzzle after having found the solution than when I first solved it. So yeah, I hope you enjoyed the video. This was my first infinite puzzle and I really enjoyed it, so thank you Phistomefel for setting this. And I'll see you guys next time. Take care.